HVAC 360 is brought to you today by Camping Vacations. The great outdoors. Tired of the built environment? Get away from cell signals, the comforts of home, and all that healthy food. Remember the good old days, fishing, laughing, and relaxing by a fire with your favorite adult beverage. Next time you think vacation, think Camping Vacation. Brought to you by the North Shore Raccoon Council, who reminds you to just leave your food laying around. We'll take care of it. What's up? Welcome back. This is episode number 91. Matt Nelson here, your host for HVAC 360, helping you go further and faster in the field of HVAC. Our purpose here is really to share stories, interview industry experts, and add to your HVAC knowledge base. So, if you're new here, and I've kind of said this over and over again, but I think it's definitely, if you appreciate the content that you get in these HVAC 360 podcasts, I think you should go over to HVAC360.com and sign up for my list. We share just a short weekly newsletter. I share more stuff there, more stories, play some games, have a photo flaw game that we play weekly, and generally share more free learning opportunities as well there. So, all right, and the best part is, like I said, I keep them short. So, what's up for this week? This week, I just wanted to get on and share about a couple of lessons learned that I had with a recent project where I commissioned a whole bunch of 4-pipe fan coil units and wanted to kind of share that with you. So, I'll do that after a brief word from our sponsor. All right, so what did I learn? I learned a number of things. This was one of the second jobs that I did involving the 4-pipe fan coil unit. So I'm kind of wrapping up a bunch of lessons learned for you. And I guess the first thing I have to say is this is a kind of a mid-rise apartments. They used a 4-pipe fan coil system, so it was kind of deluxe in that sense. And I remember talking to the engineer about this project way back when, and she was a little disheartened about, hey, I'm getting assigned to this, this apartment building, and it's apartments. There's nothing too exciting about it. And I remember looking around, I go, you know what? There is nothing exciting about it, but if you get one apartment right and you get the whole layout kind of right, then you don't have problems. Because if you have problems, if you make one mistake in a simple design where it's magnified over multiple suites, you really got a big problem. So if something's simple and you're doing a lot of it, spend a little extra time to make sure that you're doing everything exactly right. I guess that's really the lesson learned here, because if you do not, then it's just going to magnify itself. So that's one of the first lessons learned. Moving on to design thoughts. Okay, so what happened in this particular project? The 4 pipes were kind of tucked behind the fan coil unit. I know you can't really see it, so I'm going to try to visually describe it for you. But imagine that you enter the suite, and there's a closet to your left, and all you see is the faceplate of the fan coil unit. The rest of the unit is in that closet. It's a utility closet, and what they had done is they had kind of tucked, and it's probably about, I don't know, maybe like 6 inches deeper. The closet's 6 inches deeper than the actual unit itself. So there's a little space, and then tucked in behind in this dead space where you can't really get to are the four pipes, plus a condensate drain. So it was actually 5 pipes. And this kind of went up and down as a riser all the way through the building. Now, that is really, really hard to get to. There's a couple of different things that you really have to think about in designing that. I mean, on paper, it looks great, but you don't really know exactly what the construction sequence is. If you think about, placing, if the unit was placed in the right spot the first time around, and they built all the walls around it. That's one way you can think about it. But what if it's the last thing that gets put into place, and then they have to add some of the pipes behind it? I think that's a lot of times engineers don't necessarily think about construction sequences, but that's kind of, in this case, this is what happened to it. In fact, these units, and I guess maybe it's more typical for them to just be, put in a room and then walled around, say in a hotel or something like that. But you really, they were really tall. They were actually taller than a standard door opening. So when they built the room and then they got the units delivered, they had to kind of shimmy them up into this small storage room where they're going to be set. And then they cut the opening in the storage room and they kind of moved it in front there. So construction sequence is something that you need to think about and how it's actually going to be put in there. So are these things going to be accessible? I know that a lot of engineers would be like, well, you don't really want to see the pipes and that's kind of ugly and this, that, and the other thing. But realistically, there's a number of problems that occur when you start hiding things if it's not accessible. And some of the things is that the units were placed and then you had to make some of the piping was already pre-assembled with the unit, which is good, but there were still pipe joints, and they used the ProPress system. If you're not familiar with that, go look it up. The ProPress system, they used the ProPress system to make the connections behind the units. So if you're a contractor and you are thin, short, or, thin or short, you were kind of pegged for this kind of duty. There are spots that really, when engineers just kind of throw things in there, it's going to be you that's going behind the units. And they know, and they don't really appreciate it. They want their skills to shine, but they don't want to necessarily be given a job just because of their physical parameters. So anyway, that's to boot, I guess I couldn't even get my head and shoulders to look around the unit to actually inspect it. I had to use a mirror for all the units, and that was kind of something that is either hit or miss. I'm using a mirror to kind of look at everything. Things could be hidden. The inspection wasn't perfect. I did the best I could, and that's all you really can ask in this sort of situation. But if you want your design to be, really, inspected, really to work well, you have to consider all these things. There was even some openings, and I guess you can kind of have some construction sequence concerns here, where when you start drilling into the concrete, you can lay out the walls on the floor, and you can kind of like put a track down or whatever the general contractor typically does. They might just snap a line to where the walls are going to go, and then to actually cut holes for the risers, they have to core drill the concrete. So they're going to pour the concrete, and this was a concrete slab, so they had to core drill the holes. And are you going to get those holes precisely where you absolutely need them? No, they're going to be a little off. Generally speaking, they're going to be okay. But if you're anticipating that you're going to be able to tuck everything tight up against the wall, and it's going to go, wall, pipes, unit, and they're just going to be, really exact. It's not going to happen that way. And the problem is that in this one particular unit, one suite, is that they needed that to happen. Of course, it didn't happen, and the unit ended up being interfered with the door swing. So once you put the door on, you couldn't open it up. So they ended up trying to, shove the unit back as much as they could. They did a few modifications, and they got the clearance just right, just enough. I'm sure if the door expands, due to some, thermal variation during the summertime, it may stick a little bit, or it might just start rubbing up against the unit and kind of wearing off some of the paint. So that is something that you need to definitely think about when you're laying out design. What about responsibility? When you talk about commissioning, there are certain contractors take certain responsibility. Who's going to do everything? You, as a designer, you're like, okay, well, it's just the mechanical contractor's responsibility, right? Well, a lot of times it doesn't play out that way. And I guess I'll give you the scenario of this particular project where you had the prime mechanical contractor. They were doing most of the just sheet metal work. And, you can have sheet metal work, you can have piping work, and they can be done by different contractors. Well, the plumber was doing the piping in this case, and then the mechanical contractor was just doing the equipment and the sheet metal. So you kind of get this, who's responsible for what, and really where that came into effect, especially when you factor in the equipment manufacturer, is who's ultimately responsible for performing the startup of this equipment. Sometimes it's going, and it all depends on, who buys the equipment, what kind of things that they bought it with. Did they buy the startup with it? Did they not buy the startup with it? Or did they, is this one of the things that they forgot? So it could be that ultimately the mechanical contractor is going to be responsible for it, but, he'd like to have somebody else do it, especially when it's like 77 units here. So it's something that's going to take, a lot of time to do, going through the entire building. And now I talk a little bit about sampling. I think I probably touched on this before, but sampling and commissioning, it's by the book. Sampling is part of the game. However, I'm not a big fan of sampling. And, I guess sampling in this case, since it's a mid-rise building, the contractor did a really great job on the upper floors. However, the very first floor, which happened to be the second floor, the very first floor that was installed was actually done by another contractor. They switched installing contractors after the second floor. So there were some issues with the second floor units for whatever reason. It doesn't seem like it would be the type of thing that you could blame on the installing contractor, but for whatever reason, the second floor had a number of units that were just, there was something wrong with them. So if you sampled the upper floors, you could have completely missed the issues on the second floor. And that is kind of why I don't necessarily believe in sampling. I kind of take the tack that if you're going to, commission equipment, you can commission. I would rather commission equipment at just a higher level, so you don't go into as much detail and do all of it, rather than go into great detail just on a few samplings. In this case where you have multiple fan coil units like this, you could have sampled, 10% of, what you've installed. And that would be completely acceptable per the guidelines. You may even have kicked it up to 30% if you wanted to be extra sure, but you're still going to miss things. The problem is that especially if the startup was so varied, you're gonna run into situations where there's things that are wrong. So what could be wrong? Well, a lot of the units they weren't started up. I get on site and they're just not on. So it's like not only are they not working. We have the chilled water; it's up and running, and we want to be able to test out these units. So you have to look. It is the breaker on the inside. There was a disconnect switch on the inside. Is that on? Okay, you flip that on. Still no power. Okay, what do you go to next? Well, there's a panel in every single suite, so you go to that. Is that on? Is the main breaker off? And that's the sort of thing that you want to be very careful. If something's off at the breaker panel, you definitely want to talk to the electrician before you do anything. This is totally a safety thing, and you really want to make sure that if the whoever's in charge of the electrical foreman says, "Hey, no, we have these off because we're working in this one area," you just leave it and move on, and you make note of it. But sometimes they're like, in this case, it was like, I don't know. It was just turned off. So you were able to, and there was no reason why any of these suites, why they were turned off. So, but again, there's a process of communication that you need to go through. Don't just always assume that you can go and turn stuff on, especially in a panel. So once you get the unit on, are the valves working? And that's something that in this case, sometimes they're hard to see. In this case, they were pretty obvious to see. But I think the one interesting thing in the lesson learned that I'm going to pass on here is that you don't necessarily, valves, once the unit just gets started up, there is a certain kind of, I don't know, it seems like a break-in protocol for these valves. And again, they weren't necessarily started up by somebody who did it every day. And this may not necessarily even be, they might just say, hey, this is more of a product, something that's kind of generic, that doesn't get a specific startup form. They just turn it on and let it go. It should work, right? Well, the valves didn't necessarily do that. The thing that you needed to do and the thing that you needed to understand is that, hey, you need to put it into cooling mode. You needed to put it into heating mode. You needed to put it into cooling mode again. And then everything worked the way it should. The valves just needed to kind of get, they needed to exercise once through their complete cycle, because some were stuck open, some, well, not stuck necessarily, but some were, open, some were closed. So you needed to cycle them to get them into a configuration that matched the thermostat, so what you would expect. And that was something that, is a little bit different. A lot of times, too, these valves, and each situation is rather different. Sometimes I've run into situations where these valves aren't mounted, where the actuators aren't mounted to the valves, and you find the valves or the actuators just free rotating on the valves, so they're not connected. Sometimes they weren't reacting like they should, and a few of the times, it's just a matter of these quick connects inside the unit. Sometimes the quick connects, they're very touchy, and they, I don't know if they necessarily go bad, but if you kind of squeeze them, or if you disconnect them and reconnect them, all of a sudden the valve starts working for no particular reason other than you just kind of confirmed that yes, in fact, it was together. There's a few units where the actuator wasn't plugged in. There was a plug that was just kind of dangling there, and you could just kind of plug it in and get it to work. And this is some of the things that, you could be the kind of commissioning agent that goes in and just kind of notes everything. But this is, becomes a big problem, that you get a big long list that's just, it's open, and it's identified, but you have to have somebody else go in and fix it. Where, you take the approach that I do, is this is something relatively simple. I will note it on my, checklists. I'll plug it in, I'll check it, make sure it works, and I'll move on. It is, it's something that you just take care of. Don't put it back on the contractor to make a huge long list, especially in this situation where, there's 77 of these things. So you have to go through and make sure each one's working, because if not, you're really kind of doing this as a service to the owner, because ultimately they want to be able to move people in there and start renting it and get revenue. So you don't want to be that kind of person that, hey, you know what, it's going to get on a list. I'm going to send to the contractor. The contractor is going to look at it for a couple of weeks, then you're going to get back to it. We just didn't have the time in this case, but it's still not, if it's something that you can fix quickly and it doesn't take a lot of time and it's not technical, definitely do it. Just do it, note it, and say you fixed it. So it gets on the list. You identified it, that you had to do it, and just move on. I mean, there's other scenarios that I run into. If the valve's not, mounted correctly, okay, that's kind of beyond you. If there was, a unit where the valves were shut off, so I turned on the valves and the chilled water, everything was fine. I turned on the hot water, and all of a sudden, there's a huge spray of water. So I, shut it off real quick, and that's a piping leak that needs to be addressed by the contractor. There's nothing I can do about it. So there's a lot to do with the valves and checking them out, and just kind of making sure that everything's working right. Now, what about performance? Performance on these things, it either works or it doesn't. I guess a couple of different things that I look for when I'm checking out fan coil units, and what I like to do is kind of, turn it into cooling mode, let it run for a while, and what you'll end up seeing is that there's going to be, the pipes are going to end up sweating. So they should be sweating inside the unit. If there's chilled water in there, you're going to get moisture condensing on the pipes, and that kind of confirms to me, at least, that chilled water is flowing through that side of the coil. On the heating side, if you have the heat operating, open that up, put it into heating mode, and then if it gets warm, that's a clear signal that it is at least heating. A lot of times what you might find in units like these where they get airbound, and depending on how it's constructed, how it's started up, there are some things that you can do in the design of it to prevent a lot of air from getting into the system. But there's vents on the coils typically, and those you can vent out. I mean, typically that should be one of those things that was done by the startup people, but in some scenarios, that's just you gotta bleed some air for them, just to kind of speed things along and make sure things are running okay. You want to be able to rule out the fact that it's airbound and not some other problem that you're not detecting because there's a lot of air in the coil, again, air gets stuck in the coil. It just happens. So that's one of the things that you can do to make sure that the heating and cooling is working correctly on a performance basis. And typically, in situations like this, I'll usually go floor by floor or area by area and just kind of set it to coolings and let it run, maybe even overnight, and see if those spaces get to set point. You may not necessarily, depending on the size of the coils and the size of the spaces, you may not necessarily see that right away. So you might have to let it run for a couple of hours. But that's a good indication that you're meeting set point. The reason that I do that in this scenario is that these are, even though they're kind of smart thermostats, they're not networked together. So it's not like I can trend them through the building automation system. That's not an option. So you really have to go through and make sure that, okay, all the units are heating, all the units are cooling, and that they're working properly. I mean, if you already checked the valves, I think you've kind of narrowed it down to a few things, but still there might be, for whatever reason, it might not heat or cool properly. So you need to be able to kind of identify those areas and kind of mark those for the mechanical contractor to get back to. So I think that pretty much covers all the different things. I mean, it's one of those projects that you just end up, going again, and you go through these units, take them off, put them back on, and really take a look at it. It's kind of a little fun experiment that you can kind of test these out. It takes a little bit longer, but still, you don't spend a ton of time going through it. I probably spent maybe like 5-10 minutes, per fan coil unit. Probably closer to 5. But just the most of the testing is involved in, or most of the time is taking off all the covers and getting it ready and then putting it back, putting it back together. And again, this is pretty simple. I mean, this kind of, the fan coils, even like cabinet unit heaters, things like that, you can typically, if you have like a screwdriver, if you get one of those 8-in-1 screwdrivers where you can kind of, it also, you can take out the little the bit and you can use it on some of the sheet metal screws of the hex heads. That's very useful. And also just like an Allen key. If you have a set of those, that helps. I mean, typically that's all you need to get into units like these. So that's all I have to share. So, hey, that's a wrap for this week. I appreciate you taking your time. If you have any feedback on this topic or any of the topics that we cover, or if you want to just, send me a note, you can reach me at matt@hvac360.com. I greatly appreciate all of you listening. I hope this was helpful. If you know somebody who's looking into designing things like this, fan coil systems or otherwise, why don't you go ahead and share this episode with them? It increases the value of your relationship. As I mentioned at the top of the show, get on the list at hvac360.com. There's a lot of different things with the community that we're doing there. Again, games, extra information, extra educational opportunities. We may even start giveaways. So that's some of the things that if you're part of that community, then you're going to be eligible for that. So definitely get signed up for that. Go to that hvac360.com and do that if you can do one thing. If you can do something else, go to iTunes, and a 5-star review would be greatly appreciated. That does help bring this to the forefront of other people, like-minded people such as yourself. So that's a wrap for this week. HVAC 360. I'm Matt Nelson, helping you go further and faster in the field of HVAC. And as always, know what you build and share what you know.